Question 9. Ecologists have long wondered how thousands of microscopic phytoplankton species can live together near ocean surfaces, competing for the same resources. According to conventional wisdom, one species should emerge after outcompeting the rest. So why do so many species remain? Ecologists' many efforts to explain this phenomenon still haven't uncovered a satisfactory explanation. Text 2. Ecologist Michael Behrenfeld and colleagues have connected phytoplankton's diversity to their microscopic size. Because these organisms are so tiny, they are spaced relatively far apart from each other in ocean water and, moreover, experience that water as a relatively dense substance. This, in turn, makes it hard for them to move around and interact with one another. Therefore, says Behrenfeld's team, direct competition among phytoplankton probably happens much less than previously thought. Based on the texts, how would Behrenfeld and colleagues, in Text 2, most likely respond to the conventional wisdom discussed in Text 1? A. By arguing that it is based on a misconception about phytoplankton species competing with one another. B. By asserting that it fails to recognize that routine replenishment of ocean nutrients prevents competition between phytoplankton species. C. By suggesting that their own findings help clarify how phytoplankton species are able to compete with larger organisms. D. By recommending that more ecologists focus their research on how competition among phytoplankton species is increased with water density.
We have text 1 where ecologists are wondering how thousands of microscopic phytoplankton species can live together competing for the same resources. They have the conventional wisdom that one species should emerge after outcompeting the rest. So one species should compete with everything and only one should be alive. So ecologists' many efforts to explain this phenomena still haven't uncovered a satisfactory explanation. Text 2 is now talking about ecologist Michael Behrenfeld and colleagues who have connected phytoplankton's diversity to their microscopic size. These organisms are so tiny and they are very far apart from each other, and they don't even compete with each other according to what he says. The water is relatively dense, and because of this it makes it hard for them to move around and interact. So how will they compete if they are not interacting? That's what he says. Therefore, says Behrenfeld's team, direct competition among phytoplankton probably happens much less than previously thought. Based on this, if text 2, that is Behrenfeld colleagues, how they will respond to conventional wisdom which is discussed in text 1, which should we choose? So if you said A, well done, that is the best answer. Choice is the best answer because on text 2, it represents how Behrenfeld and colleagues would most likely respond to the conventional wisdom discussed in text 1. The conventional wisdom cited holds the opinion that when there is a species diversity within the phytoplankton population, one species should emerge after outcompeting the rest. That is, after being so successful in competing for resources that the other species vanish from the population. However, text 2 explains that according to Behrenfeld and colleagues, phytoplankton are so small and spaced so far apart in the water that there is much less direct competition for resources within the phytoplankton populations than scientists had previously thought. Choice B is incorrect because text 2 never discusses whether routine replenishment of ocean nutrients affects competition between phytoplankton species. Choice C is incorrect because the interspecies competition discussed in both texts is specifically between phytoplankton species, and neither text considers whether phytoplankton compete for resources with larger non-phytoplankton species. Choice D is incorrect because according to text 2, Behrenfeld and colleagues argue that water density decreases, not increases, competition between phytoplankton species.